Good afternoon and welcome to the 2021 SHU Racing Launch event. Thank you for taking the time to watch and see the progress that the team has made throughout the year. My name is Alice Boot and I'm the team principal for the 2021 season. This year's internal combustion car may look familiar as it's also the car that the team raced in 2019, which placed 21st at the Formula Student UK event. The opportunity to race a vehicle again is not something that the Institute of Mechanical Engineers have ever offered before and has been introduced as a result of numerous lockdowns. At the start of this season, SHU Racing set out with the intention of designing a new car with a hybrid monocoque chassis, the design of which was largely finalised around Christmas. This plan was then altered in early 2021, with the team choosing to re-race the 2019 car and make modifications to facilitate the car performing even better on the second time out. This then allowed us to continue our research into future developments for next year's team to implement. Throughout this video, the managers will be discussing their departments and the work they've carried out this year. We hope you enjoy.
Hi, I'm Nathan Prentice. I'm the powertrain lead here at SHU Racing. This year we'll be using this power unit once again. This is the KTM EXC500. We've been using this engine for quite a few years now, and we like it because it's so compact. So it gives us quite a lot of freedom around the rear end of the car in terms of suspension design and aerodynamic design. And this year we've really been targeting an improvement in efficiency from this power unit. So we began that by redesigning the engine's air intake system. Using our in-house 3D printed capabilities, we've manufactured an FDM printed CRP plenum with an SLS printed aluminium runner. In order to bring the noise of the overall exhaust noise of the car down, we also redesigned the car's exhaust system, this time with a pre-muffler, which not only does it reduce the overall exhaust noise, but it reduces backflow exhaust gases into the engine, again improved efficiency. With help from our partners at SHU Racing, we've been able to develop a more efficient engine map. With help from our partners at Ricardo, for the first time we've been able to validate our powertrain performance in the design stage. We estimate that this vehicle will have a 5% increase in peak power and an 8% increase in torque at 4,000 RPM.
Hi everyone, I'm Jack Boyce, the electrical manager for this year. For the past year, the focus of the electrical department has been on making modifications to the wiring harness to improve its serviceability. To this end, service loops have been implemented across the harness. These provide both strain relief, reducing the effects of vibration on the connectors, and providing excess wire to facilitate easy repairs in the event of damage without having to rerun the entire length of the wire. A bus bar was also implemented to reduce the weight of the harness and to make repairs easier to distribution wiring.
Go.
Hi, I'm Harry and I'm the Aero and Bodywork Manager for the 2021 season. In 2017, the team were able to develop and manufacture the first aero kit on a SHU Racing car, consisting of a front and rear wing. For competition in 2021, we've decided to redesign the aero devices, both front and rear wing. This is done to improve the aero performance of the car, theoretically, but also to improve the manufacturing quality. Overall, the CFD simulations suggest an overall improvement in downforce of 43%, whilst reducing the drag by 3%. Furthermore, the aerodynamic balance was an important consideration within the design of the car. Therefore, we've been able to achieve 45% front loading in the car in the aim of assisting the drivability. In terms of manufacture, we've been able to manufacture all of the aero surfaces in-house using CNC-made aluminium molds. These were then used to lay up the carbon fibre pre-preg, and then the silicon intensifier was placed inside the mould to apply pressure to the upper and lower surfaces. This whole design process and manufacture process has resulted in a 4 kilogram weight saving for the aero to introduce you to our concept class team.
Good afternoon. My name is Elijah Santos, and I'm here to introduce to you for the first time ever a vehicle created by the newly formed SHU Racing development team, which will be competing in this year's Formula Student Concept class down at Silverstone, and for which I have been the team principal over the last year. I have had the pleasure and honor of working with this team over the last year to overcome many challenges which have come our way, and the product of all this hard work is a car which incorporates many engineering firsts at the university in its history in the Formula Student competition. So the Formula Student concept class was set up as a way for new teams who are joining the competition to enter the static events and get feedback for their designs without having to make the large financial commitment of building a complete vehicle for the event. Because of this, the class also lends itself to teams who operate on longer development cycles for their cars. So this means they can bring a car in, or their initial designs for a car in 1 year, and get feedback on it before they bring in the final version the following year to compete in all the events and hopefully score better points than they otherwise would have. So with this in mind, the SHU Racing development team was set up with the purpose of developing new technologies for use in future cars at the competition. So we set out this year with the goal of designing and building an EV which would act as proof of concept, and it would allow us to collect data which we could use in our future car builds. However, with SHU Racing moving to a second year vehicle entry, we've ended up adopting, integrating and continuing the development of a lot of their designs into our vehicle. So now I'd like to hand over to the rest of the team, who will talk you through their designs for this year's vehicle. And remember, feel free to ask any questions in the chat, and we'll do our best to answer them.
Hi, my name's Ollie and I am the driver and chassis team member for the SHU Racing 2021 team. Traditionally, SHU Racing has utilised a steel space frame chassis due to material costs, design simplicity and lack of specialised machinery required when compared to other manufacturing methods. As SHU Racing has seen a major advancement and development over the past 2 years, the 2021 concept EV chassis has been designed as a carbon fibre hybrid monocoque that uses a space frame rear bulkhead, same as what you can see here, and a carbon fibre hull which will be replaced here. Carbon fibre has a magnitude of advantages over the traditional steel space frame chassis, some of which include reduced weight, increased torsion stiffness and increased design freedom. In order to enter a carbon composite material chassis into Formula Student competition, a variety of tests must be performed to ensure that the shear strength and energy absorption upon failure of the laminar configuration meet the minimum requirements set by the AMA. These tests include a 3-point bend test and perimeter shear test that can be seen on screen. The key design philosophy for the 2021 EV concept car was low-cost design for manufacture, or known as DFM. This has been achieved by assembling the mould from laser-cut CNC bent sheet aluminium panels that are then TIG welded together and bonded into position. The final chassis design, which can be seen again on screen, achieved a 26% weight saving, a 15% reduction in roll rates, and a whopping 81% increase in torsional stiffness when compared to the 2019 chassis.
So when designing the rear roll structure of our vehicle, I set out with a few clear goals in mind. Firstly, I wanted this rear to be able to accommodate both an electric and an ICE powertrain. This would allow for the team to run either powertrain in the future without the need to redesign the entire rear end. Secondly, I wanted to reduce the number of chassis members in the rear of the vehicle. This was to reduce the manufacturing time, reduce the material costs, as well as the overall weight in the rear. The challenge here was that this needed to be done without reducing the rear roll stiffness significantly, and thus negatively affecting the performance of the vehicle at the event. So my final two goals were to mount all of the suspension points to nodes on the chassis, and this way increase the structural integrity. And I wanted to increase the space within the cockpit to make it easier for the driver's environment manager and the steering manager to optimize the driver position, as this had been fed back to us by previous drivers. So these goals were achieved by building an entire chassis around the suspension mounts, and this was agreed upon early in the process with the suspension manager, and then incorporating the other design requirements in a way that didn't affect the suspension and therefore the overall vehicle dynamics. With the move to a backplate design, I was able to reduce the number of structural members in the rear section. This reduction of members was also done by making the top engine mount a removable member, which is not necessary in the construction of the EV, but it can be reinstalled if needed later. This allowed me to meet my goal of a rear end which could accommodate both powertrain types. And to increase the cockpit size, the main roll hoop was angled backwards, which allowed for the driver to be placed further back. This angling combined with the increased wall thickness of the rear tubing, which was required to protect the accumulator from side impact in case of an accident, also allowed for the torsional stiffness to be maintained at a level which met the original design requirements which I'd laid out.
Hello, my name is Dominic Jepson and I am the Head of Manufacturing and Impact Attenuator Manager for the SHU Racing team this year. In previous years, the Impact Attenuator, or IA, has been a component of the car that has been overlooked and seen as a component that did not lend itself to much designer freedom. In previous years, the design of the IA consisted of aluminium honeycomb and separated by aluminium sheets. The design was primitive and unattractive but effective, and it thus cost us design points at the competition each year. This year has been the first year that the IA has been given a department unto itself. This allows for greater advancements in the design to bring it in line with modern techniques and methodologies. And with that, I present the 2021 Impact Attenuator. In year with this year's theme of carbon fibre development, the Impact Attenuator consists of a structural nose cone made of 8 layers of stepped carbon fibre weave. This allows for the IA and nose to be combined, resulting in a weight reduction at the front end of the vehicle and an IA being aesthetically pleasing. In addition to the IA, the anti-intrusion plate has also been developed using 16 layers of carbon fibre. This in turn produces a plate that can withstand a force equivalent to 12 tons before critical failure occurs. Combined, these designs eliminate the need for additional bodywork and separate impact attenuator assembly, allowing for a total weight saving of 38% compared with that of previous year's designs.
Hi, I'm Ewan Ridley, a steering system manager for SHU Racing 2021. The steering system design for the 2021 SHU Racing Development Concept Class vehicle has had a strong focus on creating and implementing a design which minimises the steering effort for the driver. We've designed a simple and lightweight upper steering column to be mounted to the new monocoque, and an improved steering column routing over previous year's designs has been achieved to reduce the frictional and mechanical losses through the system in the UJs and support bearings for the column. Focus on compliance has been placed in the system, and reducing this as far as practical has led the department to develop a steering geometry with an exceptionally large toe base of roughly 75mm, maximising on the available space within the wheel and while still retaining a high ratio of roughly 3.7. This translates to us using a quick rack to achieve 240-degree lock-to-lock steering translation, or more clearly, this can be described as 90-degree steering wheel input achieving a 25-degree outside wheel angle, or 120-degree steering wheel input to achieve a 30-degree outside wheel angle, enabling the driver to benefit from the best balance of control in fast corners whilst enabling a hairpin to be comfortably driven with the full control of 2 hands on the wheel. In close collaboration with the suspension manager and the wheels, hubs, uprights and brakes manager, spindle length has been balanced against scrub radius to control steer torque and kickback, and mechanical and pneumatic trail have been balanced to control breakaway feedback to the driver. And finally, bump steer, roll steer and ride steer have all been mitigated as far as being practical throughout heave and roll for the vehicle.
Hello, my name's Jake. I'm the SHU Racing Suspension Manager. In 2021, SHU Racing developed the most advanced suspension system within its history. This has come about through the use of an advanced Excel spreadsheet which utilises first principles of suspension design. This spreadsheet then feeds into a one-to-one CAD model of the assembly, which is updated real time as values are altered within the spreadsheet. This has allowed us to see the effects of different suspension geometries within the real world and how it will affect the overall assembly. The 2021 car utilises an inboard front suspension assembly using machined components. This has allowed for a 30% reduction in parts compared to the 2020 design and a 70% reduction in parts compared to the 2019 design. The 2021 SHU Racing former student car also utilises a machined rear backplate in place of a welded rear bulkhead on the chassis. This rear backplate is removable and contains mountings for the rear suspension wishbones, the differential mounts and other auxiliary electrical components. As the 2021 design was initially centred around an IC and EV car, this backplate is interchangeable with both powertrain systems. The use of a rear backplate has also led to a change in the rear suspension assembly, which has also moved inboard. The 2021 suspension geometry also incorporates anti-squat and anti-dive within its wishbone geometries. This allows for a stable, consistent ride height compared to previous year's designs. With the use of an aerodynamic package on the 2021 car, having a stable ride height will allow for a greater operating window for the aerodynamic package.
Hi there, my name's Connor Waterman and I'm the Wheels, Hubs, Uprights and Braking System Manager for SHU Racing. The main focus for 2021 has been to reduce mass across all four corners of the vehicle. One of the main ways we've done this is by selecting a smaller tyre diameter. So for 2021 we're running a 16-inch tyre versus an 18-inch tyre used in the previous years. Another example of mass reduction has been in our hubs assembly. So this is one of our prototypes for the new car, and this is using a 7000 series aluminium. Additionally, we've used 7000 series aluminium for our uprights, and this has resulted in a 46% reduction in our upright and 30% reduction in our hub. Some of the main improvements we've made is the use of an integrated wheel speed ring to measure the speed of all four corners. Additionally, we've created a new integrated tripod housing such that we don't need CV joints, which save around 2 kilos per corner, so quite a significant mass reduction there. And overall, this has resulted in one of the most improved wheel hub assemblies for SHU Racing.
As the team has begun to design an electric vehicle, the requirements of the driver's environment department have changed from previous years. One example of this is the pedal box no longer requires a clutch pedal, which has in turn significantly increased the amount of design freedom. The base plate has been split in two, with each pedal working as its own sub-assembly. This has allowed for a significant weight reduction overall of 63% on our previous model. An over-travel stop has also been incorporated in both the brake and throttle pedal. By utilising the same design for the two different pedals, a continued consideration of DFMA, design for manufacture and assembly, has been made to reduce the cost associated with the pedal box too. Another component requiring significant work was the firewall. At the start of the year, the overall aim was to improve the functionality of the part, which was awkward to fit into the car. As such, the single panel firewall was instead designed in 3 pieces. This allowed the 2 side panels to be left in position at all times, whilst the centre panel could be easily removed and replaced in the car as required. In addition to this, a no-mix pressboard layer has also been incorporated to meet the additional requirements of the FSUK regulations of an electric vehicle. To improve the manufacture of the firewall, the sheet metal CAD tool within SolidWorks was utilised. As a monocoque has been designed, the CAD model will be more representative of the final chassis in comparison to a welded steel space frame. This allowed the component to be moulded and then converted to a flat pattern with all bends pre-positioned and with the additional material accounted for. This will allow the team to produce the firewall panels correctly the first time. Overall, the department as a whole has reduced in weight by just over a third this year across its components. In addition, the manufacture and assembly of the vehicle has also been improved, which has in turn increased the functionality of the sub-assemblies.
The focus of the electrical department for the electric vehicle has been to develop a concept harness design, including the necessary tractive system, active light and pre-charge PCBs. The telemetry system has also been developed. Its main use is to collect sensor data on the car's performance during the event to help further inform future design decisions whilst allowing team members to remotely monitor the data.
Hi, my name's Josh and I'm the drivetrain manager for SHU Racing Development's first electric vehicle. As this is our first EV, the powertrain department is broken up into two smaller roles, drivetrain and control systems. With no previous EV plans to work from, there was a lot of design freedom when developing the drivetrain system. A modular design was created to allow for the removal of key components such as the motor, shaft, bearing housing, which can be removed without having to detach the differential and the drive shafts. To keep the system lightweight, aluminium brackets and mounts were analysed by simulating the loads through the mounting system, which allowed for the removal of unnecessary material to make the drivetrain as light as possible. Both driven and driving sprockets are made out of international standards and allow for the use of standard chains and also allows them to be manufactured in-house to reduce the cost as much as possible. The drivetrain utilises a train-driven system with a high-torque electric motor with a top speed of 76 miles an hour and a 0 to 60 time of 4 seconds. As is the first iteration of the EV drivetrain, there is still a lot of optimisation possible, and I look forward to seeing what the team can do in the future.
Hello, my name is Jennifer Jones and I've been the Control Systems Manager this year. The primary focus throughout this year was the design of an accumulator to power the electric vehicle and the sourcing of the subsequent management and control systems. The main primary design constraints surrounding the accumulator and control systems were the Formula Student regulations, health and safety, most notably sufficient cooling of the battery pack and the packaging of the components within the chassis. The accumulator is housed within a welded aluminium casing containing insulated internal walls with sufficient cooling channels throughout. The EV powertrain is powered by 90 lithium-ion building blocks containing 6 cells connected in series. These building blocks were chosen due to their fire-resistant casing to meet the appropriate regulations and additionally the integration of 2 fuses per cell to increase safety. The accumulator is active cooled using 2 fans located at the front of the aluminium housing, feeding cooling air through a designed channel system throughout. The design of the accumulator was subject to both finite element analysis and computational fluid dynamics in order to ensure the ability to withstand the loads experienced and to provide sufficient cooling flow. The accumulator and fans are controlled by the Orion BMS2 battery management system, enabling the vitals of the battery to be monitored, whilst also enabling cell balancing to prevent thermal imbalance. A DTI HV500 motor controller and RLS encoder has been sourced to control the speed and torque of the motor. Both the motor and motor controller are subsequently cooled by a liquid cooling system, allowing for increased efficiency of the system. Thank you very much.
To end our presentation, we must say a few thank yous to people who without their assistance the car would not be complete. Firstly, to our sponsors, thank you for your continued support in the most difficult of years. We hope to continue to build on these partnerships in years to come. Next, our thanks must be offered to the 2020 team who set us up with a launch pad from which we could continue to develop our most technically advanced car to date. Finally, we offer our thanks to Sheffield Hallam University, our faculty advisor David Clegg, and all the technicians, specifically Matt and Rob, for your continued support of Formula Student being offered as an extracurricular activity at the university. The students of SHU Racing are very grateful for the opportunity not only to build and race a car, but also for the chance to put our degrees into practice and gain hands-on experience. The team are now making the final preparations before travelling down to Silverstone on the 21st of July. Updates will be provided via the team's social media during the event, so make sure to give us a follow. If you have any questions about anything we've presented today, please don't hesitate to leave a question in the comments. Thank you for watching.